Hi there, welcome to section 6.5. We're still talking about systems of equations, but we are applying systems of equations. So this is two parts. One, deciding what is the best method to use, and one is to take word problems. So we've got two options here, or two things that we're looking at, best method and word problems. So first of all, graphing. I'm guessing that not many people are going to graph to solve a system, but if the equations are in mx plus b form, you might. Or if I say to you, you must graph these to solve, those would be two options. And remember, you can't always get a real exact solution if you're graphing, if they don't meet at a nice neat grid mark. So if you only need an estimate of the solutions, I know it's in quadrant 1 and they're both positive. So you might not have the best, most precise answers. Substitution. I would use substitution if one of the variables has a coefficient of 1, like 2x plus y equals 7. So my y value is already a 1, or my y coefficient is already a 1, so it's easy to put in isolated, so the y is isolated, or if it's already solved for the variable, like when I minus 2x and minus 2x, y equals 7 minus 2x. That'd be easy to substitute, so in the other equation, wherever I see a y, I can put a 7 minus 2x in them. Elimination, they put these as two separate because we did these in two separate sections. However, elimination and elimination with multiplication, if one variable already has a common coefficient, just go for it. Remember, everything needs to be in standard form or all lined up, x's, y's, equal signs. And I would use elimination with multiplication if none of the coefficients are equal to 1 and neither variable can easily be eliminated. So if I've got to do some work and they're not easy to solve for one of the variables to do substitution. So kind of elimination with multiplication, make sure everything's lined up in standard form, and then figure out what you can make a common coefficient with opposite signs. So sometimes, you know, the last case scenario, worst case scenario, is elimination with multiplication because the other stuff is just too hard to put it in that form. Probably you won't graph very often unless I say you must graph these. Right? So now let's talk about solving word problems. The reason we mention that best method is because I'm gonna just give you some word problems and say, figure it out. And so you're gonna have to determine what is the best way to solve that. So the first thing you're gonna do is choose two variables. You can choose x and y. You can choose P for popcorn and S for soda. You can choose whatever variables you like. I usually pick ones that I can remember which one it is. You're going to write two equations. Read carefully, look for keywords, the sum of, is for equals, those kinds of things. Typically in these word problems, each sentence will be its own equation. So sentence 1 will be one equation, sentence 2 will be the second equation. Remember, you'll have the two variables in each equation. Solve using the method that seems best to you, and write your answer as an ordered pair. I'll be able to figure it out based on your numbers if you did the math correctly. So the hardest part is writing those two equations. So let's do an example or two. Let's start off with talking about, let's talk about, I'm just going to give you. Let's skip problem number 1. However, let's not skip it totally. Let's determine the best method to solve that system. Would you graph this system and find the intersection of the two lines? Would you do substitution? Would you get one of the variables by itself and put that equation into the other equation? Would you do elimination? If you did elimination, would you need to multiply? I personally would probably do elimination. Number 1, everything is nice and neat and lined up and in standard form. Notice how our x's are lined up, y's, equal signs, and numbers. I also noticed that if I wanted to eliminate the x's, I would have to multiply the second equation. I would want to make both of those guys 4's, right? And I'd have to make that a -4 for the second equation, and then I'd be able to do elimination. You may have noticed, though, that you could do substitution because you could get that x by itself by subtracting 2y. So you would have x equals a -2y plus 14. So you may want to do substitution. If you did that, you'd go into your first equation. Wherever you see an x, you'd put -2y plus 4. You'd do the distributive property and solve for y. Don't forget to go back and find the second value. If you find x first, find y. If you find y first, find x. How about in this one? 4x minus 2y equals 14 and y equals x. What would be your best or easiest method? Would you graph these guys? The first equation would be a little tough to graph. We'd have some ugly numbers and we'd have to divide, but we could still do it. It actually wouldn't be as bad as it looks. The second one is easy, right? Our y-intercept is 0 and our slope is 1. So you could graph them, but that seems like a lot of work. Would you do substitution? I noticed substitution because my second equation, it tells me that y equals x. So in that first equation, wherever I see a y, I'm going to put an x in place of it, and then I can go ahead and solve it. If I wanted to do elimination for this, I'd have to subtract the x. So I would have my first equation not change. I'd have my second equation, -x plus y equals 0. And then I'd have to multiply. So that seems like more work to me than just substituting that x value into y wherever I see it. But both ways will work and both ways will get you the same answer. Sometimes people they've got elimination figured out and they're always going to do elimination. So it's up to you entirely. Make sure that I can see your work so I know what you're doing and how I can help you if you don't get the answer. So we're going to have a few problems where I ask you just solve it. Do whatever works best for you. Then we've got a word problem. Zach has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Allie is a new volunteer, so she hasn't volunteered at all yet, but she plans to volunteer 5 hours each week. Write and solve a system of equations to find out how long it will be until they have volunteered the same number of hours. So I'm going to use a Z for Zach, and I'm going to use actually, I don't like this one. Well, I guess we could do. So Zach has volunteered 50 hours plus 3 hours every week. Allie has volunteered 0 hours, but she plans to volunteer 5 hours every week. How many variables do I have in this equation right now? For this system, I've got a Z, an A, and a W. I don't like that, right? But notice the very last line. How long will it be until they have volunteered the same number of hours? In other words, I want Zach's hours to be equal to Allie's hours. So really what I'm doing is I'm doing a substitution. In place of the Zach's hours, I'm going to put in a 50 plus 3W. In place of Allie's hours, I'm going to put in 0 plus 5W with an equal sign in the middle. So this won't be as hard to solve. It's a little bit different from ones, but I wanted to make sure I did an example where it says we want them to be the same. So we take each equation and set them equal to each other, because if they're equal, they're the same. So I'm going to minus this 3W. So I have left a 50 equals 2W. Everybody knows we're going to divide by 2, which means that W should be equal to 25 weeks. So in 25 weeks, Zach and Allie will have volunteered the same number of hours. because Allie's doing more hours every week. Zach's doing fewer, but he started off with 50, so she had to play some catch up. So in 25 weeks, they would be equal. So that one was a substitution, but kind of a different one. So let's do a different one. Let's talk about hot dogs and pops. So it costs $5.25 to buy 3 hot dogs and 2 pops. It costs $6.25 to purchase 5 pops and 2 hot dogs. Write and solve a system to find the costs of hot dogs and pops. So guess what variables I'm going to use? I'm going to use an H for hot dog, and I'm going to use a P for pop. Remember I said when we were talking about this, typically each sentence is its own equation. So equation number 1 is this. How would you write $5.25 to buy 3 hot dogs and 2 pops? $5.25 is what you have to pay to buy 3 hot dogs and 2 pops. Right? Does that make sense? So what's our second equation going to look like then? It's $6.25 to purchase 5 pops and 2 hot dogs. $6.25 will get us 5 pops plus 2 hot dogs. Write and solve a system. We just wrote a system. However, we didn't solve it yet. So what do you want to do to solve? Do you want to do elimination, substitution, graphing? When I look at my numbers in front of my H's and P's, which by the way are not lined up, please make sure you notice that, they are not easy to work with. So what I'm going to do is I'm just going to rewrite them. So I'll keep 3H plus 2P equals 525. I always like my numbers, plain numbers on the other side. I'm going to take this equation and rewrite that, but I'm going to put the 2H so the H's are lined up. 5P, $6.25. It's okay to have decimals, that's no big deal. So now would it be easier, if we're going to do elimination, and you don't have to, but I think it's the easiest way, would it be easier to eliminate the H's or the P's? If we've got 3H and 2H, that would multiply to give us 6, right? 6 is the smallest number. If we did 2P and 5P, we could do a 10. Either one will work, it doesn't matter. I'll just do the H's since they're right there. So my top equation, to get that 3H to become a 6, I'm going to multiply by 2. My second equation, to get that 2H to become a 6, I'm going to multiply by 3. And then what kind of 3? Because I want my signs to be opposite. So make that a negative, right? So now my first equation, when I multiply everything by 2, 6H plus 4P equals $10.50. When I multiply my second equation by negative 3, I'd have a negative 6H minus 15P equals, what will that be, a negative $18.75? Kind of mind-boggling, but once you get to this part, easy peasy, right? What's 6H minus 6H? Big old nothing. 4P minus 15P, negative 11P. And when I do 1050 minus 1875, that's a negative 825. Divide both sides by negative 11. Please grab your calculators. I'm hoping that I've done my math right. Negative divided by negative becomes a positive, so a pop should be, what is that, 75 cents? So I'm going to plug in to any one of my equations. I'll go to one of my top ones. My very top equation, it says 3H plus 2P equals 525. 3H plus 2P. And we just found that a pop is 75 cents. So 3H plus $1.50 equals 525. Subtract that $1.50 from both sides. So 3 hot dogs should cost us $3.75. So 1 hot dog should cost us $1.25. So my ordered pair, I would go alphabetical with the way that you wrote them, so H's and P's. So the H will come first, the P will come second. So a hot dog is $1.25, a pop is 75 cents, And this is our ordered pair. Kind of strange to work with decimals, but when you think about it in money, it's really not as weird as it looks. Right? So, let's write another inequality or another system of equations, and then I'm going to tell you that let's solve it later. You solve it on your own. So number 5, it says the sum of two numbers is 70. One number is 10 more than twice the other number. Find the numbers. So I'm going to start with x and y because it didn't really tell me. So x is the first number, y is the second number. So remember, each sentence is really its own equation. So the sum of two numbers is 70. What does sum tell you you're doing? So wouldn't you agree that tells us then that x plus y equals 70? Second sentence tells us one number is 10 more than twice the other number. Well, that's a bit overwhelming until I notice this is right here. So I know I've got an equal sign, right? So what's one number or my first number? 10 more than twice the other. How's that equation look to everybody? Find the numbers. So how would you solve this system if our two equations are x plus y equals 70 and x equals 10 plus 2y? This one looks like it might be a really good time to use substitution, right? Because it tells us what x is equal to. So wherever I see an x in this equation, I could put a 10 plus 2y. So this part right here was an x in that original equation. I put that 10 plus 2y and substituted for it. And then I can solve. I can combine my like terms. 2y plus y is 3y. I would go ahead and minus my 10. So 3y equals 60. Divide by 3. So y equals 20. And then this one you might even just be able to think it through. Our first equation said that x plus y equals 70. And we just found that y is 20. So what does x have to be? So our ordered pair would be 50, comma, 20. Once you get the hang of setting them up, then you just go back to our solving things. And this is why what we talked about, that best method, what seems like the best way to solve. So let's skip number 6. Here's what I need to know from you. What are the steps to solving a word problem that involves a system? So how do you actually do them? Don't write out the question, just write out the answer. And I want you to write the system. If you want to solve it, go ahead, but I want you to write it. James bought 4 t-shirts and 3 pairs of jeans for $181. Sarah bought 1 t-shirt and 2 pairs of jeans for $94. The t-shirts were all the same price. The jeans were all the same price. Write a system for the situation. So pick your variables. Are you going to use T's and J's? Remember, each sentence is typically its own equation. So sentence 1 gives you one equation, sentence 2 gives you the other equation. If you got that system pretty easy, go ahead and solve it. I'll tell you what the answer is when we talk about it in class. Jot down anything that you may have missed that I didn't give you enough information for that we need to talk about to make sure that you have all of the blanks filled in that you need in order to do these. We'll see you next time. Have a great day. That's it for lesson 6-5.